Radio-controlled cars have captivated hobbyists for decades, offering a thrilling blend of speed, maneuverability, and remote control excitement. These miniature vehicles have evolved significantly since their inception, incorporating increasingly sophisticated technology and capabilities. Today, we stand on the cusp of a new era in RC car design, where the fusion of microcontrollers like Arduino and Wi-Fi modules like Nodemcu paves the way for unparalleled control and customization. This project will guide you through the process of building your very own RC car from scratch, empowering you to experience the exhilaration of creating a functional robotic vehicle with your own hands. Along the way, you'll gain valuable insights into the worlds of electronics, programming, and wireless communication. Skills that extend far beyond the realms of RC cars and into the ever-expanding domains of robotics and the Internet of Things. Whether you're a seasoned maker or a curious beginner, this journey promises to be both educational and immensely rewarding. This comprehensive guide will equip you with the knowledge and tools necessary to transform a collection of components into a responsive and agile RC car. We will delve into the intricacies of assembling the car's chassis, mounting the motors and wheels, and wiring the electronics with precision. Furthermore, you'll master the art of programming the Arduino and Nodemcu, enabling seamless wireless control over your creation. By the end of this journey, you'll not only possess a fully functional RC car, but also a profound understanding of the principles that govern its operation. Get ready to embark on an exciting adventure into the world of DIY robotics and unleash your inner maker. Before we embark on the construction of our RC car, it's essential to gather all the necessary tools and components. Having everything readily available will streamline the assembly process and prevent any frustrating interruptions. Fear not, for the materials required are readily accessible from online retailers or your local electronics store. Tools of the trade: 1. Soldering iron and solder. These are indispensable for creating secure electrical connections between components. 2. Wire strippers, essential for removing insulation from wires, exposing the conductive core for soldering. 3. Screwdrivers, both Phillips and flathead, a variety of sizes, will come in handy for securing screws and fastening components. 4. Pliers, useful for gripping, bending and cutting wires and other small parts. 5. Hot glue gun, provides a quick and effective way to secure components in place, especially when dealing with vibrations. Electronic components: 1. Arduino Uno R3 board, the brains of our operation, responsible for processing inputs and controlling the motors. 2. Nodemcu ESP8266 Wi-Fi module, enables wireless communication between the RC car and your smartphone or computer. 3. L298N motor driver module, acts as an intermediary between the Arduino Nodemcu and the motors, allowing for precise speed and direction control. 4. DC motors, you'll need 4 of them, provide the driving force for our RC car, enabling it to move forward, backward, left and right. 5. Wheels, also 4. These will be attached to the motors, allowing the car to roll smoothly over surfaces. 6. Battery holder with batteries, supplies power to the Arduino, Nodemcu and motors. 7. Jumper wires, used for making temporary connections between components during testing and prototyping. 8. Breadboard, optional, useful for prototyping and testing circuits before soldering. Chassis and structural components. 1. RC car chassis, provides the structural framework for our vehicle. Various designs are available. Choose one that suits your preferences. 2. Screws, nuts and bolts, essential for attaching components to the chassis and securing the structure. 3. Cable ties, optional, help keep wires organized and prevent tangling. With all the necessary tools and components at your disposal, you're well prepared to embark on the exciting journey of building your very own RC car. In the next section, we'll delve into the first stage of construction: assembling the chassis. The chassis serves as the backbone of your RC car, providing a stable platform for mounting all the electronic components, motors and wheels. The choice of chassis design ultimately depends on your preferences and the intended use of your RC car. Pre-made chassis kits are readily available online and at hobby stores. offering a convenient and standardized starting point. If you're feeling adventurous and prefer a more hands-on approach, you can opt to build your own chassis from scratch, using materials like acrylic, wood, or even Lego bricks. This allows for greater customization and the satisfaction of creating a truly unique vehicle. Regardless of your chosen chassis, the assembly process typically involves securing the motor mounts, battery holder, and any additional structural supports using screws, nuts, and bolts. Refer to the instructions provided with your chassis kit, or design for specific guidance on assembly. Once the chassis is assembled, take a moment to admire your handiwork. This sturdy framework will soon transform into a dynamic and responsive RC car. But first, we need to equip it with the means of locomotion motors and wheels. With the chassis assembled, it's time to install the motors and wheels that will propel your RC car to life. Most RC car chassis come with designated mounting points for motors, typically located on the underside of the vehicle. Carefully attach the motors to their respective mounts using screws and nuts, ensuring they are securely fastened. Next, slide the wheels onto the motor shafts, making sure they are properly aligned and spin freely. Some wheels may require the use of hex nuts to secure them to the motor shafts. Once all 4 motors and wheels are in place, give the car a gentle push to ensure everything rolls smoothly. If you encounter any resistance or wobbling, double-check the motor mounts and wheel alignments. A smooth rolling chassis is crucial for optimal performance and maneuverability.